Let's look at some more examples. So, absolute value of 2 minus 5x is greater than or equal to negative 4. We don't have to do this at all, right? Because it's an absolute value. We know that it's always going to be 0 or positive. So if we want to find out what kind of values of x can we plug in so that it's greater than or equal to negative 4, it's going to be all the values, right? So anything that you plug in, because it's an absolute value, is always going to be greater than a negative number. So that one is done. And the next one we have 4x minus 7 is less than negative 3. Kind of the same concept here, but on the other end, right? If we have an absolute value, it's always going to be 0 or positive, so it can never be less than a negative number. So for this one, there's nothing that we can plug into x so that we get a negative number. The next one that we have is absolute value of 5x plus 15 is equal to 0. So although we have absolute value, the only time it can equal to 0 is if it is 0. So for this one, we only have to solve for when it's equal to 0, because there's no other absolute values that you can take to get to 0 other than itself. So subtract 15, we get 5x equals negative 15. And if we divide by 5, we get x equals negative 3. So you can check that by plugging that in. Negative 3 times 5 is negative 15, plus 15 is 0. So our solution is negative 3 for that one. Now, sometimes you're going to have to convert words into inequalities. So the first example that I have is k is no less than 5 units from 8. So since it's no less than, it means k is greater than or equal to 5 units from 8, right? So we can, instead of no less than, we can say greater than or equal to. So we are saying between k and 8, there's at least 5 units, right? So between k and 8, I can find that distance by subtracting them and taking the absolute value. I want it to have greater than or equal to 5 units. So greater than or equal to 5. Okay, it's a bit tricky when you first encounter words that you haven't seen, but with practice it'll become a little bit easier. The next one that I have is n is within 0.001 of 6. So if we say within, we're comparing n and 6, right? So n minus 6, the distance, is within 0.001. Within meaning it's below, right? If I say it's within 0.001, it means it's less than 0.001. Finally, when we talk about tolerance, it means within, right? So it can be within a certain amount, but once it goes over, something goes wrong. So the example is if y equals 2x plus 1, and we want y to be within 0.01 of 4. So once again, we're comparing y and 4. So we do y minus 4, and I want it within 0.01. So I want it less than 0.01. You can also write 0.01. And then substitute the 2x. So I have 2x plus 1 minus 4 is less than 0.01. And if you solve this, you get 2x minus 3, the absolute value, is less than 0.01. And since it's a less than, we can set up the inequality. So let me go here and set up some space. So 0.01, 2x minus 3 less than 0.01. right? So since it's within, it can either be greater than negative 0.01, but definitely less than 0.01 to be within a distance of 0.01. And then you do the same. So we add 3 to both sides, actually to all sides, right? So we get 2.99 here, we get 2x in the middle, and then we get 3.01. And then we divide by 2. So we get 1.495 less than x, which is less than 1.505. So that's your final answer. If x is between 1.495 and 1.505, then y will be within 0.01 of 4.